Next up, we get to install our clutch bearing block, so we need bags 12, 1 and 2 for this. In bag 1 there's the nicely machined bearing block with a couple of bearings there for the starter shaft. It's rubber former mounted basically to give some damping within the frames, and the novel feature of this is that we can actually preload the mounting with this damper here of the clutch block within the frame, so allow a little bit of movement when the frames twist, so they don't actually bind onto the starter shaft and actually slow down the motor. Another little novel Kasama design feature. Before we mount the clutch block, it's as well to decide whether or not you're going to use a conventional governor mounted sensor, in which case you want to take out the carbon plate down here, which is mounted on this CNC governor mounts here. You can see how the end of the mount almost butts up onto the magnets cut out on the fan. And this has got a couple, you can't quite see it here, this has got a couple of holes pre-drilled in it for your sensor mount. So if you're going to use that, take it out now, mount the sensor up. You can just take out 3 bolts basically, 1 on the right, 2 on the left, and take out the whole assembly here. I'm not going to use this because I'm using the R7100R with the sensor already mounted on the crankcase back shaft. First off, from bag 1, the 2 bearings, spacer and O-ring are already pre-mounted into the assembly, but we might have to service that in the future. Damper block is rather interesting. It's got recesses for the O-rings, which we can easily place in there now. For the bearings, it's actually got a lubrication slot on there. You see it says oil with a diagram with a hole down there and an arrow pointing to that. We've got this unusual mounting system here, which is like a mini swash. It's a ball joint basically there, and these aluminium folders which attach to the frame are going to go into this ball joint here and give it the capability of having some lateral movement basically, which is a very clever feature, and that's going to allow the frames to twist a little bit, as they inevitably do, without binding on the starter shaft on here, and thence taking away power from the engine. No idea how much difference this is going to make, but it's a very novel feature, and as far as I know, unique to the Kasama design. So we're pushing our formers from either side. You got to put them in squarely because there's no real tolerance there at all. And if you're interested, the markings on this are Ico manufacturer, made in Japan, and it's got the markings there, GE6E, whatever that is, but for those bearing files amongst you, you can look that up yourself. Next up, we've got to take our clutch block assembly. The oil logo is pointing towards the top, and slide that over the starter shaft, and then just get these dampers flush between the sides, and then you can push that fully home until you see the mounting holes and the damper holes lining up with the cutouts in the carbon frame. Before we can secure the clutch mounting block in place, we've got to adjust the backlash between the pinion and the main gear. And the way we do that is to loosen the bottom engine, the side mounts basically on the engine, in the bottom center plate down here. There's the 4 M3 bolts. Loosen those off, and so you can then slide the engine backwards and forwards without rocking, so you only want to minimally loosen these. Loosen it up so you can move it backwards and forwards, which we'll do now. You can see we've got an adjustment now, forwards and backwards on our engine mount. And then you can hold the clutch steady and you can rock the pinion gear until you get your desired amount of backlash. If you listen now, that's the minimum amount of backlash, and that turns really well on the pinion. That's our 0.3 to 5 millimeters again. That's probably a little bit much, so I might just sneak that in a bit. Or the time-honoured way is to get a strip of plastic and, oops, spot on the camera, put that down between the gear and the main gear, and then just tighten up, and there shouldn't be any backlash with the plastic in, but there should be a minimal amount with it out. And once you're satisfied with that, do up again the 4 bottom mounting plates, bolts, 2 on each side. Once you've got that right, you'll find the engine and flywheel turning over nice and smoothly there. But if we do it the other direction and I'm moving the bevel gear, it's actually binding, so we're too tight on here. So I think the thing to do is pinion main gear and float first, then do your bevel gear, and lastly do your clutch mounting block. So I'll get those 2 sorted out there now. And if you're feeling it binding as you're pushing it round, it's too tight. In actual fact, there's a bit of a tilt on this, which is removed by doing up the bolts. So you need to leave in just a little bit more backlash than you would like prior to tightening the bolts up, because it's going to reduce it when you do those 4 bolts up on the bottom engine mount. And there's dinner arrived, which looks like it's barbecued pork tonight.
Just a great low rate, and for a limited time, it's...
Here's the mounting hardware for the clutch mounting block from bag 12-2. Put the O-rings into the mounting the damper mountings, and put the special washers on the M4 bolt, and have its M4 lock nut and the 2 M3 bolts ready. First off, the M4 bolt goes through that funny little swivel damper at the rear with its washer, and we can loosely put the lock nut on the back, and this basically gives the mounting block room to slide on this. Then we offer up the mounting dampers. As explained before, we're going to keep these right to left, so we'll actually put a mark on one side so that we preserve the orientation in the future, but just for now we'll gently place them and start to screw up so that the moulded interior on the mounting dampers goes into the recess on the carbon frames just before the M3 bolt goes into the mounting block. The way you set your dampers is to screw in the bolt until you first feel the increase in resistance of the O-ring start to be compressed against the O-frame. And then for head speed 1600 to 1900, Kasama says you should be able to turn half a turn, or if you're going to fly over 1900, then 3/4 of a turn. Now I can get 3/4 of a turn on that, no problems at all. If I couldn't, then it means that the inside of this former is too long, in which case we'd have to sand this down a little bit, make this upright a bit smaller, and to allow a little bit more compression on the damper ring. But that side, I'm going to put it in. I can't imagine me really doing much over 1900, so I'm going to put it in just a tad over half a turn, and obviously we're going to need to Loctite those. So initial pressure there, half a turn, and there's still a little bit of excess there that I could increase the pressure on the damper if I wanted to. And once the M3 bolts have been Loctited in, just over a half turn, we can then do up the M4 lock nut. Once that's secured, make sure the starter shaft runs round nice and freely without any binding, and that's the appearances from above. Very elegant. Next up, out of bag 13, there's the fan shroud. This is a very high quality moulded item. There's no flash there to see at all. It's got our Kasama part number down in there, and this is glass reinforced plastic. You can get the impression of the glass on there. There's 2 M2 bolts that hold the sides together, one at the bottom, one at the top just there. This comes ready assembled. What we have to do first is we've got some frame spacers. We have to push 3 of these down into the mounting lugs. They're a bit of a tight fit, but once you get them started, they go down fairly well and get them in nice and flush. And once you've done that with all 3, you can then turn your attention to the frame, where we've got to go a little bit retro, and in order to get the this one's a bit tighter, and they're going to be secured in with the mounting hardware, which is our M3 by 32mm collar bolts and their respective washers and lock nuts down there. To get the fan shroud in, as I was saying, we've got to split the frame. This is going to be a bit, good practice for the future, I'd say. And it's quite simple to do. All we've got to do is 4 of the M3 by 32 collar bolts going from the bottom of the frames through the centre mount. Just liberate these 4, and then the frames will lift off, and then we can assemble the shroud with the spacers going in the cutouts in the frame. 1, 2, 3, just down there. Okay, that's our 4 bolts out, and just look at this. Lift the top off. Now, the starter shaft is normally going to have a coupler on the top of it, but that's only going to be 1 hex bolt to come off. But look how easy it's going to be to service this clutch. 4 bolts, lift the clutch off, and you're onto your clutch down there. That's just brilliant. Okay, now we'll mate up the fan shroud into the frames, and then we'll do a trial lower down on the engine and see if it all fits. No big surprises here. The frames lay flat on the side. Just locate the fan one first of all, and then it slides up and it all mates up perfectly with our spacers. So we'll put the collar bolts in there now, and then we'll lower it down onto the bottom half of the frame and check it out for. Everything slides back again nicely. Don't forget to put your clutch back. It's not worth doing up these fan shroud bolts, the 3 of them, until you've got the frame secured, because you've got a little bit of adjustments there just to make sure that there's no chaffing of the fan on the shroud at all. So we'll do up our 4 mainframe attachment bolts at the bottom there. Then we'll check for position, and very little clearance down there. You can see that fan. Not very good lights there, but there's not much. In actual fact, the fan doesn't quite extend, diameter doesn't quite extend all the way out to the actual shroud. There is a little bit of a gap down there, so that's good, but obviously we want to just get it right, so it's not going to chaff at all. And that's our fan in place. View from the top, and view from below, and that's been fixed in firmly in place now. Okay, what next? Anti-rotation bracket. We're on to bag 14 now, which is page 23 in the manual, with our anti-rotation device, mounting bracket for the elevator servo crank down here, and the rear canopy mounts, and another mount for the spindles for the aileron cyclic servos. First up, out of bag 14.2, we have to install the ball links into the elevator lever arm. So with the orientation of the longer centre hub, the one ball link goes in on the outside of the short arm, and it goes in on the inside of the longer arm. So we'll just Loctite those in now. First up, we've got to mount the elevator arm lever brackets onto the anti-rotation device. The shorter spaced holes basically are the ones that go onto the anti-rotation bracket. There's a bit of a gotcha here. They're not quite the same. One of the brackets has got a right angle in. The other one is reinforced a bit more with a fillet in there. Make sure you put the one with the right angle on the non-machine side of the bracket, and the one with the fillet in put on the machine side of the bracket. Otherwise you'll find you won't be able to fit it onto the tapered back edge of the frames. So we'll just secure that now with these M3 by 15mm bolts. That's our assembled arms. No point doing these up tight until you've got the elevator lever arm put on, which we can do now. We take our lever arm. The short arm faces towards the back. The M3 by 28 bolt has gone down through the middle. The 0.5mm shim washer has gone on the M3 bolt. That then can go down through the levers. First of all, we need to put this aluminium spacer down, flat non-machine side pointing to the front. Pop the bolt down and mount up the lever arm, and then we can secure those with an M3 washer and an M3 lock nut. Now we've got the M3 shaft going through the lever, we can now tighten up these bracket mounting bolts on the anti-rotation device. And that's the M3 shaft bolt done up enough so that there's no end play, but it's quite free to spin round, and our two secure levers on the anti-rotation bracket like that. Now we can mount up the anti-rotation bracket onto the frame, lever to the back. First off, we have an M3 by 40mm, by 28mm rather, and a threaded rod that goes through the top hole, and then our threaded canopy standoffs will be Loctited down on there. If you just see now, the bottom is secured by another one of our M3 by 32 collared bolts, and this is in an oval on the helicopter, and this means the anti-rotation bracket can pivot on the canopy mount threaded rod, and that will allow us to take the swash in and out. Conventionally, you bend back a plastic anti-rotation device, but there's no way you're going to be able to bend this, so that's why you've got to have this tilt system. So we'll do that up loosely now. We'll lock tight on our canopy mounts, and then we'll loosely do up the bottom bolt until we've got the until the swash plate is mounted. And that's the rear view of our anti-rotation device and mounted elevator lever. Nice simple job now. I like the easy ones, just securing our cyclic servo shafts onto the upper bearing block, flanges pointing towards the front, and Loctited in with two M3 by 6mm, and that's our starter coupling with its two M2.5 by 6mm bolts, a combination of clamp and fits into a machined recess. Very nice too, and that looks like it takes our standard 6mm starter shaft. That's all for now. Next time up we'll be doing the servo mounts with those interesting looking torque tube couplings up to the unusual kinky swash plates. So I'll see you next time.